All right, so first we don't have a training set or test set here, so I'm going to remove this line of code. I'm going to, remove that as well, all the index selections and here as well, and I'm just keeping X. And then let's see what we have to do. All right, so first that's already more clean. Now, with what we have here, these 3 lines of code, we are indeed applying feature scaling to the matrix of features X, which is one of the things we have to do indeed. That's good. However, as we've just explained, we also have to scale the dependent variable vector, the salaries. And of course, and that's the important thing you had to understand and figure out, we're not going to use the same standard scalar object on both the matrix of features X and the dependent variable vector Y. Why is that? That's because, when you fit your object SC on your data, well, it is going to compute the mean and the standard deviation of that same variable. And therefore, since, of course, we don't have the same mean and same standard deviation for our levels here and our salaries, well, obviously, we have to create 2 standard scalar objects, one that will be fitted to X in order to compute the mean and standard deviation of the position levels, and one that will be fitted to Y to indeed compute the mean and the standard deviation of the salaries. All right, so that was the only important thing to understand. And therefore here, I'm actually going to call this SC object SCX in order to say that it's the scalar of the matrix of features X, and here SCX as well. And now I'm going to create a new standard scalar object, the one that will be used on our dependent variable vector Y, and therefore here I'm replacing SCX by, we're going to call it SCY, so that it's perfectly clear that this is the scalar of X and this is the scalar of Y. And now we're going to copy this, paste that right below, and here we'll just have 3 little replacements to do, which are first replacing X here by Y, then SCX here by SCY, and X here by Y. So that now we're ready to scale both our matrix of features X and our dependent variable vector Y. Let's check it out. Let's run this cell. And now we're going to add 2 new code cells to print the new X and the new Y and see what they have become. All right, so 2 new code cells. And let's start here with a print of X. Good. And then a print of Y. And now let's run these 2 cells here, starting with print X. And indeed, well, we have some perfectly scaled values of the position levels going from minus 1.5, and that corresponds, of course, to position level number 1, and 1.56, which corresponds to position level number 10. All right, and now let's print Y, and this will be interesting. Here, the values will go from minus 0.7, which corresponds, of course, to the salary of $45,000 per year, and 2.64, which corresponds to the $1 million salary. And as you can see here, this time the values are in the range from -1 to +3. That's why in the data preprocessing part, I told you that usually standardization transform your values between -3 and +3.